Lesson 63 is called rational numbers, non-terminating or not ending decimals, and percents, and then fractions with negative exponents they toss in there too. Lesson 63. Recall every rational number can be expressed as a ratio. It's kind of where we get that word rational. Of two integers. Converting the ratio to a decimal number results in a decimal that either ends, terminates, or doesn't end, non-terminating. All right, so here we have 1/8. Pretty simple. I like that fraction. It's very straightforward. It's just a 1, a fraction bar, and an 8. But then if you do 1 divided by 8, right? Okay, 8 goes, the decimal rises up, and then you'll end up with 1.25, and it ends. Once we get there, because you subtract and just trust me, it stops. There's no remainder after 125. So it's a terminating 125 thousandths is the decimal. But this, if you type this in a calculator, it won't actually end. It'll just go to some spot here and it would actually keep going. It's 0.9 repeating. We usually show that with a repeat end like that. We don't perform calculations with a decimal number that has a bar over the repeating because it's not going to be exact. Instead, we want to use that fraction 1/11. If you multiply by 1/11 instead of 0.09, you're going to get a more exact number. More exact product. Right? Now, what does this have to do with our lesson? Express 2/3 as a decimal and a percent. Then express 2/3 as a decimal rounded to which place? The thousandths place. All right, we'll keep that in mind. First, let's just break this down into things. 2/3, turn it into a decimal. So we go 2 divided by 3. I don't know why it looks like this. That's weird. It's like a check mark. We need these zeros because 3 doesn't go into 2, and this rises up, right? So 3 goes into 26 times. We're still at 20. Looks like it's just gonna, I can already tell it's just gonna keep going and going and going. So the equivalent decimal is 6 repeating. Percent. All right, well then we need to move this, right, times 100. 66. And then they like to add the fraction remainder and then a percent sign. What we really do is you take 2/3 and you multiply by 100, which gives you 200/3, which reduced, made proper, is 66 2/3. So take your original fraction to get the equivalent percent, multiply by 100%. That gives you 66 2/3%. Okay, we've done the first two things. Now express it as a decimal, but rounded. So we kind of got started there with this. If it's 6 repeated, really it looks like this and keeps going. Thousandths place is tenths, hundredths, thousandths. Rounds up because 6 is bigger than 5. So it's 0.667, and we clear out the rest. So it's just this. And notice the wavy equals, that means about equal to, not exact, because we did have to round. Okay. Express 16 2/3% as a reduced fraction. So we're going from percent back to fraction. Instead of multiplying by 100%, if we're reducing it into a fraction, we're going to divide by 100%. So 16 2/3, let's go back into decimal form. Okay, so we get rid of the percents. We divide 16 2/3 by 100. To divide, we need to do this thing, right, where we turn it into a fraction, and that's 16 times 3 is 48, plus 2 is 50 over 3, and that's all being divided by 100, right? Don't get too confused where we've got these two different fraction bars. We've got this improper up here, and then we've got 100 being divided. So another way to show this is this. 50 over 3 times 1 over 100. Instead of divided by 100, we just do times 1 over 100. Okay, and you can do a lot of fun reducing here first. 50 divided by 50 is 1, 100 divided by 50 is 2. So then it's just 1 times 1 is 2, 3 times 2 is 6, 1 over 6. That's the reduced fraction. As a decimal, what do? They take that 1 over 6 then, because that's really the easiest way to get there. Do 1 divided by 6. Okay, and you end up with this, and then this is going to repeat. So it's just 0.16 repeated. So use the fraction to get the equivalent decimal. Head back to example 2 if you get more of these and you get confused. Arrange numbers from least to greatest. Just make them all in the same form. That's going to be the easiest way to do things, whether that's fractions or decimals. In this case, I think they use decimals, rounded to the same number of decimal places, 3. 4/5 is the same as 800 or 8/10. 83 1/3%. If you divide that 83 1/3 by 100% and then turn it into a fraction, then turn it into a decimal, put it to 3 places, you get 833 thousandths. And this ends at hundredth, so this is a 0. So that means this is the biggest. That's first place. Second place. Third place. Least to greatest means this one will come first, then this, right? If the person who had won the last election, which is the incumbent, received 41 2/3% of the total 1260 votes, how would we get a quick estimate of that, and how would we get a more exact number? Quick estimate would say this is closest to what very basic fraction. That's kind of like 50%, but a little less. And what's 50% of 1260? 630. What's a little less than 630? Well, it's going to be less than 630, so maybe like 600 or maybe even less than that. Less than 600. How about that? The number of votes is probably less than 600. A decent estimate, but not super exact. One way I like to do estimates, quick things, is I look at 1260. I like to always find what's 10%. And that just means what would this be divided by 10, right? So, well, we don't need this really, but I'm going to show you it. 1260 divided by 10 is 126. That's 10%, okay? Because we moved the decimal 1 over. If 126 is 10%, what's 40%? Which is about the same as 41 2/3. Well, we just multiply by 4, right? To get 10%, or 40%, sorry. So 126 times 4 is like 480-ish. 500 about. So that's like 500 votes. So now we're even closer than we were. Less than 600. How about V is about 500? Now to get really exact, we could turn this into a fraction and then multiply that because it's of 1260. How do we get this into a fraction? Let's clear everything out again. Turn this into an improper. 41 2/3 is the same as 120. Well, let's slow down. 41 times 3 is 123 plus 2, because I'm doing this thing, is 125. Okay, 125 over 3, and then we want to divide that by 100 to get the fraction, or 100% if you want to think of it that way. Okay, let's change colors. We get rid of the percents. Really what this means is 125 over 3 times 1 over 100 instead of divided by 100. Okay. Let's divide this by 10. No, by 5. So we get 20. And 25. 25 over 60. They just did 125 over 300. I guess that's kind of what I'm doing right now. 25 over 60 reduces to divide both by 5, 5 over 12. However you do it, you get to 5 over 12. Then we said multiply that by the total number of votes, 1260. You get 525. Is that less than 600? Yes. Is it close to 500? Yes. But the exact number of votes is 525. All right. So the biggest thing I think today was being able to turn a percent into a fraction. But we're going to quick toss on fractions with negative exponents. X to the negative n means 1 over x to the n. 3 to the negative 2 means 1 over 3 to the positive 2. Recall that with fractions, we reverse the position of the numerator and the denominator to form a reciprocal. So if the base of a negative exponent is a fraction, we make the exponent positive by replacing the fraction with its reciprocal. What it's saying is, in example 5, 1/3, the whole fraction to the negative 2 means if we flip it, now it's to the positive 2. Okay? Which is really the same as saying 3 to the 2 or 9. So when you look at these, they're just making sure you understand what to do with this. If everything is to the negative 3, that means to turn this to the positive 3. Okay, to make this positive, you flip the 1 down to the bottom and the 2 up to the top. Pretty much just the reciprocal to the positive version of the exponent, okay? Pick one of these, and do letter H. H, one of these and one of these, and K. So pick one, H, and J or K. So that means 4 total.